Can you hear me?
Yes. Hey, Adam, I know I said I could, we might want two note takers, but there's going to be a lot of slides and stuff. So like, I'm happy to do the whole time.
Oh, thank you very much.
One last thing to ask about here as we get started.
Much appreciated.
Thanks, Peter.
I'm here for you.
Adam, you're driving slides, right?
That's right. Trying to remember what all the icons are here for getting the slide started.
Second from the left, Adam will get you the repo from the data tracker.
The second from the left for me is gallery view.
Underneath your name in the upper left-hand corner.
Ah, there. Thank you very much. So yeah, it's my first time sharing with MeetEcho, and I'm not sure exactly what I'm supposed to be seeing. The icon is lit up, but I'm not actually seeing any slides myself.
And we can see the slides. So I think you're good to go. If you want to turn on video, you can.
Adam, you probably need to click on presenter view in the top.
Yeah, the icon on the left on the upper right, Steph.
Ah, thank you. There's the problem. Okay, just a little bit of a learning curve here. All right, so we're a couple minutes past the top of the hour here, so I think it's time to go ahead and get started. You're in the priv BOF, which should come as no surprise. There we go. So we're going to start off with the traditional note well. If this is a surprise to you, it shouldn't be. This is basically saying if you know of any patent rights associated with anything that you discuss, there are obligations that are described in BCP 79. Please go read it, and also behave yourself. That's basically the general gist here. So we have Peter St. Andre has volunteered to take notes. Initially, he was going to take it for half of the session, but he just very kindly stepped up for the entire session, so we're good there. Traditionally, we have a Jabber scribe for those folks who are not on audio but want to ask questions. Do we have someone who can just monitor the chat in case there's someone who, for whatever technical reason, can't speak, needs to have a question taken to the microphone? Okay, I think I see Chris saying yes.
Agreed.
Thank you very much.
Jonathan.
All right, so overall agenda. We have, we're gonna start out with 25 minutes from Ecker talking about PPM and how it's different from what we've done before. We're going to go through use cases from a handful of folks, and then talk about how this relates to some work going on in the CFRG research group. After that, we're going to have a bit more discussion around the charter and expressions of interest. Does anyone want to suggest changes to the agenda we have here? All right, hearing no objection. Just a few notes on this. This is a working group forming BOF. The goal is to make sure that everyone understands what the problem is that we're trying to solve. And we're going to talk about potential solutions here, but we're not going to try to improve those solutions or anything along those lines. We'll be taking questions for clarification after the first presentation that explains the problem. And then we're going to have 4 presentations on associated use cases. We're going to ask that the questions on the use cases are held until after the 4 speakers are done because they're fairly short slots and we want to get through them quickly. And those are going to be for clarification. And then we're going to talk about, as I mentioned previously, how this relates to some work going on in the CFRG. And then we have almost an hour at the end here to talk about the charter for the working group and general discussion to provide input for the security ADs and for the IASG. All right, so we're going to go ahead and hop on to Ecker's presentation here. So Ecker, if you could grab the slides.
Slides, but it does not seem to be having any impact. So I think you have to do something.
See,
there we go.
There we, yeah.
Fantastic. I'm actually, despite what it says on the agenda, I'm going to merge the discussion of the things we're trying to accomplish with the discussion of technology, because I think it's easier to understand the motivated cases. So I'll just fold them right in rather than having a separate use cases presentation. I'd also say I sent a link. I've written up quite a bunch of introductory material on this, so if people want to read that, I sent a link in the Jabber chat. And obviously, if something is unclear, please stop me and ask. Okay, let's move on. So I'd like to start. So here's just like the traditional, this is what I'm going to talk about, kind of in order. First, I want to talk about the kinds of things one actually wants to measure in these typical settings. Then I want to talk about something called anonymous measurement, which is one approach you might take to it. And then I want to talk about the kind of multi-party cryptographic techniques that are the focus of this BOF. And then I'll sort of talk about the technical architecture for the protocol that we sort of developed that are hoping to pull in this work. That's about all the signposting I plan to do. So there's a lot of situations where one would like to learn about people, right? We have the census, where there's a lot of public research, and you learn things like demographics and people's income. Maybe they have medical issues. Companies want to do product development, so to see what features that people use and don't use, how much they use them, are the products not working in some way, and then you often want to take behavioral measurements, say you want to discover new websites that no one knows about, or what information people care about, so you can tune your product to be more like what people actually want. So I mean, there was a good example of this the other day when Brave did some posting about their new search engine and how they want to discover websites for the search engine. So all these problems involve collecting data. The information, of course, is very useful, but it also is can be very, very sensitive. People often don't want to and shouldn't have to disclose their medical issues in order if we want to learn how many people have some medical condition, that's good, because we want to know where funding should be targeted, for instance. But we don't want to know what individuals have medical conditions. That's bad news, right? Same thing is true for your income and sexual orientation, all those things. Someone is unmuted, maybe it's Peter, if you could. I know it's not me because I'm not typing. It turns out that not only the things you naturally think of sensitive, but even much less sensitive data can be very revealing. And of course, this is how ad targeting works. And it turns out that there's a lot of evidence that you can put less sensitive data together. This is often called high dimensional sparse data sets, and figure things out that people would be surprised. And so I had this is from an article a few years ago about Target inferring when a girl was pregnant by looking at her other sort of purchasing behavior. There's been a lot of research on this, and one would hope to do better. And so the historical way that one does these things is that you just gather all the data and then you promise not to disclose it. This is not working out super well. There's data breaches. There's the famous case of the census information being used for targeting Japanese Americans during World War II. And so generally, it'd be better to have a system that did not involve just trusting someone to handle the data appropriately. So the good news is that actually the data that you want to know is not necessarily sensitive. The data you want to know is usually what's called aggregates. So say you want to know the distribution of people's income, maybe in a particular region, or maybe you want to look at the relationship between income and height, which by the way, there is one. Or you want to know what the most popular websites are. But I don't care what websites any individual goes to. What I care about is what websites people in aggregate go to. And in fact, it's often not useful to learn the websites that any individual goes to, because maybe a lot of them are very low cardinality and only care about popular. often you need to like slice the data in multiple ways. So you say, look, I just want to look at a given region. I want to compare two variables. I want to regress them against each other. So in these cases, it's, as I say, it's actually not useful to have the individual data beyond what lets you compute these aggregate metrics. And of course, it's very harmful to have individual data if you misuse it. And from the perspective of a researcher, not only it's not just a matter of harmful, but it's a matter of dangerous, because now you have to have all sorts of controls and procedures around handling the data that make it very hard to work with. And of course, also it makes it people unwilling to share the data with you if they think you're not going to handle it responsibly. So while there are situations in which it is necessary to gather full data and then just say, look, you have to trust me, those situations are ones we should avoid rather than foster. I want to talk a little bit about the kinds of kind of output measurements you might want. There's a number of common measurement tasks that we're hoping to achieve in this working group. So the first is what's often called the simple aggregates. This is the stuff you would like learn in an intro stats class of single figures, single group statistics that capture some data. So mean, median, sum, histograms, that kind of thing. Then there's sort of like relationships between values, correlation coefficients, ordinary least squares, that kind of stuff. People often talk like federated machine learning. That's kind of out of scope for this, but simple stuff is in scope. And then there's this specific problem that's often called heavy hitters, which is collecting common strings that a lot of people have. That turns out to be a very useful technique for number settings. So like I say, you can notice that these are all like these aggregate things. They don't depend on anybody's individual data. So we just like to find some way to gather these aggregates without having to be infected by people's individual data, which is like basically toxic waste at some level. So like, let me give you like one motivating use case. It's very useful to know what kind of sites users visit. Because then if you're like a web browser, so now we're back to like use cases. If you're like web browser, you like to know what kinds of sites people visit, so you can make your web browser work well on those sites. And so you can spend time and say, okay, well, people like really want to watch a lot of video, so like making video really work is important. Now we have like some data on this because we collect like mechanical data, but like for obvious reasons, it's unattractive to know like what topics any individual is interested in, because some of those topics are implicate information they don't want us to have. And it's very difficult to obviously knowing exactly what sites people go to is problematic, but even knowing the interest people have is problematic because you can infer other things about them. And so there's been a lot of work and trying to figure out like exactly what information is sensitive and what information is not is extremely difficult, because in some cases like some interests are sensitive, and in some cases people think other interests are not sensitive. And so there's been a lot of talk about this in the ads context of like what topics are safe. But like in an ideal world, if you didn't care about privacy, what you want to do is like bucket the sites by topic and then count the number of like minutes spent on each topic. But like I said, we can't just do that. But there's another problem statement is to collect the distribution of time spent on each type of site without actually seeing the individual sites people are. So that's like one motivating use case. Another motivating use case, again, for a browser is to see which websites are having problems of one kind or another. In some cases, these problems are I guess innocuous. So like web compatibility is a big problem. Some sites just don't render properly. And like Mozilla operates like a thing which you can like press in the upper right-hand corner of your browser somewhere that says like this site is broken for me. But we depend pretty heavily on people volunteering information because we obviously don't want to collect what URL everybody's going to. This is like a bigger problem for browsers with smaller market shares because things will often work on like one engine and not another. So in many cases, we can detect breakers on the client. We know that something's wrong, like they tried to use a property we know it doesn't exist, or like users hitting reload constantly, like rage clicking, but we can't do anything about it because like the browser knows, but it can't tell us. And so that's one example. Another example is that we know there's a lot of like what's called fingerprinting going on. So a lot of web tracking happens with cookies, but there's a lot of which happens without cookies. And so what you do is you like have a bunch of JavaScript APIs and you can measure how the browser behaves under those JavaScript APIs. So an example people often talk about is what's called canvas fingerprinting, where you like render some fonts and then you read back from the canvas, and that gives you information about like the GPU of the user's machine. So you can use this to build up a like single value which you can use to like follow the user on the internet. So this is like a big front tracking that like is not addressed by the kinds of third-party cookie blocking that browsers like Firefox and Chrome do. This is again often detectable on the client because you're like, why is this person like doing like a canvas readbacks when like they're not actually displaying anything meaningful, or like they're actually loading some like script which is a tracking script, but you just can't like report back for exactly the same privacy reason. So we're stuck in the situation where if you had like the sort of aggregate information about which sites are having problems, you could do something about it because you could go to the site and you could like download the script and find it yourself. But doing that would entail collecting browser history is problematic. One thing I would say is people often say, like, why don't you just do a scraper? And you certainly can do that sometimes, but there are two problems. One is building a scraper that collects that much information is very expensive, and the second is that it's very easy to detect when someone has a scraper, and if so, especially in these fingerprinting cases, they could just send you different data. There's other fingerprints. So again, the problem statement is to collect the sites where the client is seeing some issue, but only to see the hot ones, and only to see and not to see individually, what you just you're going to, but just to pick the sites that are most problematic in one way or another. And I'm just going to sort of preview the rest of the people here. We're talking about a number of other use cases. I guess I hit this first one, so I should have like removed that. My slides got changed. But there's a bunch of talk, I think, other use cases involving both some advertising work and also some work on COVID exposure notification measurement. You'll see those later. But I mean, this should give you a sense of the breadth of the kind of problem we have here, which is like all kinds of sensitive measurements you want to collect. That unfortunately are difficult to collect with privacy, without fancy technology of the kind we're trying to develop here. It's important to recognize there actually are two kinds of privacy threats with these kinds of data collections. The first is when you collect sensitive data and it's directly tied to identifying information. So you say, look, I did a survey and I called people on the phone and they told me, they told me this sensitive stuff. And now I have their phone number and they told me whether they have a particular medical condition. So that's like a direct tie, right? And then there's also this thing, what's called, basically this goes back to this high dimensional data sets, is often if you collect enough non-sensitive information, and then you collect one piece of sensitive information, you can use the non-sensitive information to figure out who the person is. And so there's this famous observation due to Latanya and Sweeney that if you just have 5-digit zip code, gender, and date of birth, you can identify most of the population of the United States. And so generally, and there's was a bunch of work also by Arvid and Narian about this Netflix data set where they're able to find people's, who people were by the Netflix browsing history or viewing history. So we have to solve both these problems. So the naive thing that people often talk about doing is basically what's called anonymized data collection. And this is absolutely a viable technique, and there's a bunch of work going on about it in OHI working group. And the basic idea is to strip off all the identifying meta information. And so what the client does, the client end-to-end encrypts the data to the collector. And then you have some proxy in the middle that removes all the metadata like the IP address. And so this avoids the collector seeing that meta information, but still gets, and because the data is encrypted, the proxy never sees the report, so that these things are split up. And we talked about the trust model for that, so I won't go into that in much detail. And so there are a number of ways to do this. You can do this with connection level proxies like MASC or IPsec or 20/20, or you can do it with an application level proxy like OHI. So this is a very good technique for a number of cases. It's really good for sort of boosting the privacy of semi-sensitive data, data you collect anyway. You say, well, I wish you didn't have the IP address, so you can get rid of it. And so it's very common now for browsers to collect telemetry, and we have the IP address, which you just throw away. And so we great not to have that involved. There are also a bunch of cases where you want to collect individual values and these freeform data blobs that you want to really dig into. It's also the only way to do things that need an answer. So if you actually want to have not just data collection, but you also want to have data reports, you can't do that. You don't have for that. And the techniques we're talking about don't do that. But there's a bunch of cases where it doesn't work well. And the most common cases are you can't. It's not good for these high dimensionality data sets where you need to take multiple values and put them together. And the problem is that goes back to what I was saying before. If you give me even the innocuous demographic information, I use it to identify the person. And so if you give me this data set that, for instance, consists of your zip code and your birth date and your income, well, I can map that back to you. I know your income. So I can't do it. So I can't use this if I want to do this kind of correlation because unfortunately demographic information is self-identifying. And the same thing is true if you want to do crosstabs and subgroups. It's also not good for collecting this kind of heavy hitter stuff, and the reason is because even though data is anonymized, you get all the values, even the low cardinality values, and a lot of the low cardinality values are problematic. So they might be, for instance, Google capability URLs. So the good news is, over the past 10 years, we've developed cryptographic techniques which can solve these problems. There's a bunch of fancy crypto, which I'm going to really only vaguely sketch. But the basic idea is a multi-party computation. So what the client does is the client wants to report some value, and it takes the value and it splits it up into two shares with a secret sharing technique of some kind. And the way the shares are constructed is that knowing only one share doesn't give you any information about the aggregate value, and that splitting is what's called information theoretically secure. Namely, it doesn't depend on computational assumptions. When you put the shares together, they of course represent the entire value. So what you do, each client sends like one share to one server, another share to another server, and then the servers take the shares themselves and they aggregate them. They compute the aggregate value. But again, you're just working on the partial data, so you're not learning anything. And then you could take the aggregate, so like say, for instance, you want the sum, you get a partial sum. And then you could take each partial sum and you can put them together and you get the final output. And so the key point here is that you could do all this work without ever having anybody see anybody's individual value. So let me just pause for a second before I start talking about the crypto, which is the trust model. Because this is like really important. I know this comes up a lot when we talk about these systems. So the client's requirement is the two servers do not collude. If the two servers collude, they can be individual values and it's game over, right? The servers have to operate between people, obviously, and the client has to trust exactly one of them. The client is great if the client trusts both, but as long as one of them doesn't cheat, it's fine. And you can do n servers, but 2 is the most common number, obviously. The servers also have to, for various reasons, do a little bit of enforcement about like minimum batch sizes, query limits, and stuff like that to avoid some attacks that we want to talk about here. For the collector's requirement, both servers have to actually be executing protocol correctly because either server can like distort the results if they don't. But again, this is only a correctness requirement that only one server is required to behave correctly from the client's perspective. So I just want to recognize right up front, it's like difficult to verify from the client's perspective that the servers aren't colluding. The collusion can happen through side channels. Depending on the architecture, sometimes the side channels are small, sometimes they're big. You can do point-in-time audits to verify that someone is behaving correctly, but you can't. But it's like not possible for them not colluding. And I just want to I want to highlight that. But I also want to say that like this is like a very, very common scenario on the internet where people have data and you have to trust them to behave correctly. I mean, if you think about like your data is in Gmail, like Google has like your entire mail record, right? And you're trusting them to behave correctly. And even if the software's running on your machine, like generally people think of that as behaving correctly, but like your ability to verify the software running on your device is extraordinarily limited. And so like while it would be great to have a situation in which you never had to trust anybody, that's simply not the situation most of us find ourselves in. So what we're talking about here is trying to like alleviate the situation of having to trust people and make the number of people who have to trust smaller, or the number of people who have to cheat larger, I guess. We're not talking about eliminating trust entirely. It's just not possible at this state in our technological development. And so we're trying to improve the situation, but we're not trying to like boil the ocean. I want to talk like very briefly about like one cryptographic protocol to give you a sense of like the situation. This is sort of the one that started it off. It's called priv, and it's useful for computing like numeric aggregates, like sum and mean, that kind of thing. And like this is like the one that's the most apprehensible. And like we're gonna punt the crypto to CFRG, but this one is like understandable to like normal humans. So we assume each client has some value, like say numeric value, and like call it X of I, right? And so the client does is the client splits up that value in the following way. It generates a random value. Sorry about the fancy math, but basically a random value is smaller than a prime. And then it basically does, it sends server 1 like the value minus the random value modulo the prime, and it sends server 2 the random value. And it's like it's quite easy to convince yourself that if you know that knowing the random value is not enough, and knowing that the subtraction is not enough, and that is sufficient. So now each server takes all the shares I get from everybody and they add them up, right? And again, like because these are like information theoretically secure, they're not like anything. And then they basically exchange the sums, or really like one sends the sum to the other probably. And then if you take the sums and you add them up, and you like do a bunch of relatively simple middle school math, you can just convince yourself, because addition is commutative, that when you add the sums up, you actually get the sum of the initial values. So like mission accomplished, we've done all this computation in zero knowledge, and we have the output at the end. So this seems like really boring and like kind of obvious, but it's actually fantastically powerful. And the reason is because there's a lot of things you can actually compute with just this sum thing. As long as you encode the data properly, you can compute all kinds of things as sums. So like arithmetic mean is obvious, it's sum divided by count. Product, you compute product by doing sum of the logs. Geometric mean is computed from product. You can do variance and standard deviation by computing some of the values and some of the squares. There's a bunch of fancy stuff for doing like OR and min max and even ordinary these squares. So the trick is just finding the right encoding. And there's like papers now about how to do all this stuff. So one problem that people immediately say is like, what about bogus data, right? And there are actually two kinds of bogus data. There's plausible data, but it's actually false. So like I'm like about like 175 centimeters tall, but may I say I'm 180, right? This is like a problem with any surveying technique unless you collect the data yourself and you just live with it. You have to live with the noisy data, right? Because people don't lie consistently. And then there's like completely ridiculous data, or I like say like I'm a kilometer tall, or worse, I say like I'm negative kilometer tall, right? And ordinarily what you do is you just like have some filter mechanism where you said, you just said like, well, I just reject anything this is a kilometer tall, right? But like with the priv, the data is encrypted, so you can't do that, right? And so instead what you do is like, and this is the fancy math part, each submission comes with a zero knowledge proof of validity. And the proof says something like, this height report is like between like 100 and 200 centimeters, right? The servers work together to validate the proof, and you only aggregate the submissions that have valid proofs, right? So like, you have to trust me this part works, but like this part works. But it's important to remember that this part, believing this part works, is not necessarily required for believing privacy. The privacy claim comes to the previous things. You just believe zero knowledge proofs don't leak the data. So like going back to my use cases, right? Say I want to collect these user interests, right? So basically the way you collect user interests with a thing like Prio is that every user interest gets a bucket, and you have like, I don't know, 100, 200, 500 buckets, right? And the clients individually report the time spent in each bucket. You have to report the ones that are 0 to otherwise you can just look at which buckets are reported. And then use Prio sum up and end up with a bunch of sums, one for each bucket. And now you know exactly how much aggregate time was spent on each bucket but you don't know anybody's individual time spent. And as I know, you can also report t squared, you can compute standard deviation as well. So this is like a pretty straightforward application of something like Prio. But there's like a whole pile of use cases that basically come into this. Even more fancy is a protocol called heavy hitters. Well, actually, they didn't name it, so like we've been calling it hits. And the idea is that like each client submits a string, like a URL, and you want to output the n most frequent strings. And I'm going to like very, very aggressively hand-wave this, but the basic idea is that the servers can jointly compute the number of strings at any given prefix p. And so what you do is you start with like basically you just do binary search. So you start with like strings start with 0, and you say how many strings start with 0 versus start with 1, and then okay, fine, now I'll keep going down the tree until I've gotten down to whatever threshold I want to. And so you can just find all the values and effectively all the important values in basically log n tries. And I will not even remotely attempt to explain how this works. I understood it for about the amount of time I understood quantum physics when I was in college. Again, this is like well understood math at this point. So going back to my use cases again, you can use a technique like this for conducting broken sites, right? Each client creates one report for each site that's broken or which is fingerprinting, and they use hits to determine top sites, and the servers just spit out the list of all the important sites, but you don't learn who reported them, and you don't learn any sites that aren't important because the servers just won't descend the tree once the cardinality is below a certain value. So again, this is like an example of how you can use this for like a real world application that like we actually really care about. I do one thing I want to like flag is that there is there's this issue called subset query, which is so submissions. I just giving you examples, or I'm just giving you submissions that like have one piece of information. But you can also tag the submissions with the demographic data. You can say like birthday or zip code or initials, and these things you're talking about, right? And those get passed on all the way to the aggregators, right? And this is notionally safe because you say that the nonsense information is safe, or you only collect nonsense information, and then the other data is encrypted. But then you can say, okay, compute an aggregate over the subsets. So that's like a very powerful technique. It's one reason why this is like a a powerful technique in ways that like OHI is not. But of course, it means that repeated queries can be used to determine individual values by like querying for the subset, like includes them and then excludes them. There's some defenses against this. Having minimum batch sizes, anti-replay, randomization for differential privacy. This is a piece of work the working group's gonna have to work on. That's part of why this is completely done. But I think we well understood how to do pieces of this for some measurements, and the other ones that you're gonna need some more work. So what is the state of the play here? A number of us, some of the people you're going to be presenting, have basically developed a generic protocol that is designed for doing privacy peer measurement. What I mean by generic is that it's a framework protocol that then you can plug in individual cryptographic technologies. So it's compatible with a bunch of these things called verifiable distributed aggregation functions, which we'll be talking about. But initially, it's tuned to work with PRIO and heavy hitters. It's built on top of HTTPS. It's going to smell a lot like any REST kind of protocol like Acme or whatever you've seen before, and so it's easy to implement with existing services infrastructure. And but other people working on this, like having familiar infrastructure, so they're designed to work well with this. So just to give you like a system architecture picture, this is what it looks like. There's a bunch of clients, they send their shares, and then there's like a leader, and the leader like basically takes the shares and parses them out to the helpers and orchestrates the whole computation, and then the data is like sent to a collector, and so the collector can say, look, give me like the output for this subset of the system, and then it spits the results out, right? And so one way to think about this, and I think there's a number of different deployment models it's compatible with, one of which is that the collector and the leader are the same person, and they're trying to do the data collection, and they outsource the helper job to one other person so that they can make guarantees about the privacy of the system. Another possibility is a whole like leader collector helper box is like a service that's provided to people. The trust model here you should be assuming is that the clients have to know what the helpers and leader are. And so the clients know who the data is being encrypted for, and so they can make their own assessment of whether or not they trust one of those people. Though of course, in a real world scenario, what's most likely to happen is that the clients are deployed by the collector effectively, and the collector hardwires the leader and the helper, and so that the user of the service can inspect who those people are, but it's not like they actually choose them in any meaningful way. So, people are naturally going to ask what the situation with OHI is, because OHI, as I mentioned, is useful for many of these kinds of settings. These are complements and not substitutes. So, good cases for OHI are like, as I say, sort of sanity sensitive data. This kind of rich freeform data that you couldn't really aggregate this way. Anything, of course, that needs any kind of response at all, right? Because none of this technology gives you a response. It just measures. Good cases for PPM are really sensitive data. Hopefully simpler data, because as you sort of probably getting the idea, it's not really easy to do really complicated stuff. And settings where you need to kind of do drill down, you need to do regression, or you need to do subset correspondence, that kinds of things. So these are these are two great cases to take straight together, right? You can use OHI to talk to PPM server, thus boosting the privacy of the system. So you say, okay, well, I do want to collect this data, but I actually store it at IP address, so you can remove that as well. And in fact, I think you'll see some of the some of that in later talks. You can also use sort of a front-end proxy server to do a bunch of kind of misuse detection of spamming attacks and stuff like that. So I think these are complementary techniques, not competitive techniques, which is why you see some of the same people working on them. I don't know why. Oh yeah, right. I was like, why do I have 2 more slides? So I'm now done. I think I hit my time target quite well. I have a little time for questions, which I'd be happy to take. Oh, I do want to say one more thing, but while I'm waiting to see if anybody else says anything, which is our assumption is the VDAF functions we standardized are defined in CFRG, not in IETF. And so the idea is we'll build the framework here, and we'll defer that work defining the VDAFs to CFRG, and that work is already partly going on, or at least being presented to CFRG. Wes.
Pause. Thanks. Good presentation. I enjoyed. You laid it out really well. The one thing that I'd like to hear more about is sort of the deployment scenario. For example, on slide 14, don't go back, you specifically said the client wants to report some value, right? So would your expectation be that application authors and servers would sort of make use of this in the same way that sort of Ohio is considering being deployed by various organizations to get into stuff, or that Doe is being used for everything DNS. I mean, how do you, where would this be deployed? Because the client actually, if the client is a user, right, they're clueless. So
yeah, absolutely. Yeah, I think the most likely settings for this initially will be the kind of measurements that people are already taking via the software to disseminate. So things like browser telemetry. I think the case that Tim will be talking about next involves measurement of cover exposures, and yeah, those things are all being done automatically, potentially by asking the user automatically by the software. I think there's some possibility that in the future, you'd see this used for surveying, for direct surveying, where you say are you willing to participate in surveys, and then we'll lock down the client and you can do it. But I mean, I think these are pull techniques, not push techniques fundamentally. And I think obviously cryptographically it's so complicated that the user has to involve some piece of software to do it.
Do you have a use case today that should not be used with Ohio that this would be a better for, that's already in your head for I want this now?
Yeah. So I think certainly the use case of measuring sort of misbehaving websites, it basically cannot be contained with Ohio, because you learn you learn a bunch of the you don't want to learn any of the low cardinality sites. That's very dangerous, right? Because if you collect every URL somebody goes to, even if it's misbehaving, then there's a real probability that you learn a bunch of say Google Docs, capability URLs, or you learn some document called this is my plan to buy company A, So basically anything that involves that kind of string data collection is very problematic with Ohio. Also, even this sort of bucketized give me counters, be 80 counters, really problematic with Ohio, because basically you have to decide every single value and report it separately. Otherwise, you end up in a situation where you can build these high dimensional data sets and use them to do projection. So those are both cases where Ohio does not perform particularly well. Though the second, you could maybe get away with, but it's probably problematic. Andrew.
Just by way of clarity, since Ohio has come up quite a lot in the chat as well as in your presentation, where you said complementary, there's no dependency on Ohio here. Yeah, that's what I thought. It was just worth being absolutely clear on that. Thanks.
No, not at all. Thank you. Okay, Chair. So I'll hang around, but I think then we're done, right?
Yes, thank you very much. So just for avoidance of confusion, the Mozilla use cases were folded into Ecker's presentation.
That's correct, yes. I didn't cover everything we're interested in doing, but those things we're interested in doing, yes.
Right, so we're going to roll into Tim now. If you go ahead and grab the slides. Excellent. Oh, that's the wrong slide.
Oh, I thought, excuse me, I thought you were going to put the slides up. So
I can run them if you want me to. Or
yeah, would you? I'm not sure how to upload them, and mine are nice and simple anyway. Thank you.
Sure.
Okay, I'll dive in.
And need to release. Oh, I've got it. There we go.
All right, thank you. Okay, so let's get started. My name is Tim, and I'm an engineer at the Internet Security Research Group. We're the nonprofit that operates the Let's Encrypt Certificate Authority. Not to be confused with the IRSG, incidentally. The dilemma that Mr. Rescorla just introduced, in which the essential function of gathering telemetry from the field introduces significant privacy risks for users, is of great interest to the ISRG, given our mission of reducing barriers to secure and private communications on the internet. Next slide, please. So Ecker covered that, the ways in which telemetry is a privacy risk for users, and the implied benefits to users of using these new technologies. But I think it's worth noting that many data collectors also want to do the right thing and respect the privacy of their users. Besides that being the decent thing to do, the large amount of personally identifying information stored by conventional telemetry systems is a significant liability for the data collector. There's new privacy regulations emerging in various jurisdictions all the time, which require expensive and complicated controls around user data. And all that PII makes for a very, very tempting target for attackers. So we have these new tools like priv and heavy hitters, but even those organizations with pretty formidable engineering departments who have the wherewithal to explore these techniques are in kind of a jam because you need an external trusted partner to execute these multi-party protocols. So ISRG is interested in providing private measurement aggregation as a public service to the internet for a lot of the same reasons that we built Let's Encrypt. We want to make it easy to do the right thing. Next slide, please. So we envision running a standards compliant aggregator as a service with the same focus on automation and ease of integration that drive Let's Encrypt. We expect that some customers will want to run their own aggregator and have it work with ours, but others will want to avoid running any servers at all and will instead choose two existing aggregators, say one run by ISRG and one run by some other organization or a company that chooses to participate. So in support of that, we are hoping to provide an open source implementation of a PPM aggregator with the aim of making it easy for some data collector to interoperate with ISRG's aggregator or anybody else's. So hopefully it ends up being a matter of grabbing a container image from some public registry, you deploy it into your existing Kubernetes cluster or whatever you have, and you can start gathering private telemetry cheaply and easily. Somewhat akin to how the EFF certbot can be easily deployed alongside your existing web server to have it manage Let's Encrypt TLS certificates. We are also aiming to provide open source client libraries targeting like a variety of languages and frameworks chosen to facilitate adoption for the most likely interested parties. So you can imagine like a Swift SDK for iOS apps, JavaScript for web for a single page application on the web, and so on. So with this goal in mind, an open standard through the IETF is acutely valuable because a proprietary single vendor solution wouldn't be terribly useful since the privacy guarantees are contingent upon independent and non-colluding aggregators. Next slide, please. Thank you. So we talked a lot about the benefits of these new technologies, but there are some trade-offs, some drawbacks to these systems. So for one thing, there are more servers involved, so it's more likely to fail, somewhat necessarily. Second, the verification of the proofs that Ecker introduced earlier do introduce some computational and network overhead, and in particular will introduce, depending on which protocol, which VDAF is in use, will introduce potentially multiple rounds of communication between the aggregating servers. Finally, metrics gathered under these schemes are necessarily less flexible than conventional telemetry systems. You can't make arbitrary post hoc queries. You can't make arbitrary queries post hoc against your corpus of data. You have to know upfront before you begin collecting any data what are the aggregations you're interested in computing. This has to do with the construction of the proofs, as well as enforcing some of the privacy guarantees of the system. Fortunately, in spite of all these challenges, we do have some evidence that this stuff actually works and at scale. So in December of 2020, a collaboration between Apple, Google, we at the ISRG, the Linux Foundation Public Health Initiative, the MITRE Corporation, and the National Cancer Institute at the National Institutes of Health in the United States launched the Exposure Notifications Private Analytics System. And this is the backend to Apple and Google's Exposure Notifications Express, which is a system, of course, for COVID exposure notifications. So EN, exposure notifications, of course, is the system by which mobile devices can sort of anonymously exchange with each other COVID exposure. ENPA allows anonymously and privately backhauling that data to a regional public health authority, so that they can get information on how many people are getting the notifications, how many people are on their mobile devices, how many people are interacting with them, and all sorts of interesting metrics about the spread of COVID itself, as well as the effectiveness of the EN system. So this is currently deployed in 13 US states and the District of Columbia, and at the moment it's gathering 2.1 million measurements per hour. We also heard last night, to throw in one more interesting number, that sometime over the night we gathered 12 billion individual metrics that have been aggregated since the system launched. We're also about to deploy this internationally, so beyond the United States. So we're hoping to soon turn this on in 4 states in Mexico. Okay, I'm already well over time, so I will cede the floor. Thank you.
Thank you very much, Tim. All right, Martin, you're up next. Do you want to run your slides? Do you want me to? We can't hear you, Martin.
Let's go on the next slide. Talking,
Sorry?
I can just press instead.
That was kind of broken up.
I am sorry. Is that coming through better now, or we?
I can hear you now. Yes, thanks.
Okay. Yeah, it takes some time. Where are we? I have to thank the people who provided the preview on selecting these slides, because all of these slides have the same titles. Okay, so I'm going to talk very briefly about some of the use cases in advertising, specifically the conversion measurement one. I think Charlie's going to follow up with some more details on this one. So conversion measurement is something that happens on the web quite a bit. When someone shows an advertisement, it's kind of nice to know if that advertisement is having the intended effect. And so the goal here is to measure how many people buy the widget when they saw the ad, and how many people buy the widget without seeing the ad, how many people see the ad without buying the widget, all those sorts of things, and combinations of those things for different campaigns and whatnot. This information flows to both the advertisers, the ad tech companies, and those people who actually sell the inventory or put the advertisements on their websites. So key question here is the money I'm spending on all this advertising actually having an effect on me making more money? So the way this works today is pretty simple. We assign a user an identifier, so everyone gets their own unique identifier, and every time they visit a website and an advertisement is shown or they do something, then we just create a little log record that records all the details from the context and their user identifier, timestamps, all those sorts of other things. And then you look at the log and you can answer all sorts of questions about what people have done. It's really great for getting the information that you need. It's all quite precise, leaving aside all of the complications of anti-fraud and all those sorts of other things. You can answer all the questions that you have fairly precisely. However, that doesn't really respect people's privacy, and so the idea behind some of the efforts that we're talking about here is to produce aggregate statistics about conversions without relying on user-specific logs. That means you get counts rather than individual records. Current status of this work is that there's lots and lots of requirements that are coming through. This is obviously a lot more complicated when it comes into practice. There's lots of ideas. People have all sorts of wonderful proposals and some competing requirements, but a lot of the really promising ideas include something like what Eka described earlier. And the simple example here is probably the one that is easiest to understand. You have an event that occurs, someone views an ad. You have another event that occurs, they buy an item, as maybe that's connected to that particular ad. And those are two independent events. And you can imagine those events going into some sort of opaque box that's operated by, say, their browser or something like that. And you add up some numbers, and maybe you add up a 1 if there was an ad shown and the person bought the thing. And if there was no ad shown, you add up a 0. You get those reports from thousands and thousands of people and feed them through a system like Brio or one of those other things, and you get back a count of the number of people who saw the ad and bought the product. And that allows you to make some conclusions about how your business has been operating and the advertising campaigns you're running. Obviously, this gets a lot more complicated, but we'll let Charlie explain some of that. Any questions on this part?
Okay, so is that the end of your presentation?
That is it.
Okay, let's go ahead and bring Charlie on then. Charlie, do you want me to do your slides? Or do you want to run them?
I think I can run them. Let me see. Ask to share slides. And let's see if this works.
Great.
You guys can see it?
Yep.
Okay, great. Hello, everyone. My name is Charlie Harrison. I'm a software engineer working at Google, looking at PPM-like solutions for doing ads measurement on the web to satisfy similar use cases that Martin was just talking about. So I'll kind of breeze through some of the background just because there's a lot of overlaps with Martin's slide, but I think the gist here is that here at Google, we think third-party cookies are not great for users' privacy, but they're kind of right now like critical infrastructure that powers online ads for exactly the reason Martin mentioned. And the problem that we're trying to kind of grapple with is whether we can build something like a third-party cookie alternative that gives users good privacy while still kind of supporting this like critical infrastructure to some extent. And I think the key insight here is that, at least as it relates to PPM, is that like many ads use cases are actually like totally fine with aggregate data, and they don't actually need to track you kind of around the web and learn all the data exactly. We could be fine with aggregate data in many cases. So I want to go over just in a little bit more detail how attribution measurement, which is also called conversion measurement, happens today with cookies. Essentially, and I'm sure this is going to be familiar for many people, what happens is that you typically have an ad tech site that is like running on a website and that drops cookies on, sets cookies that are readable basically from anywhere, from any website. This allows you basically to keep track of like a mega identifier sort of, which is this third-party cookie, which is tags the user or the user's device with an identifier, which is readable from multiple different contexts. So you'll read this cookie when an ad is placed, and you'll also read this cookie when there's a conversion, like when you buy something later on down the road after you've seen an ad for it. And so right now, this cookie ID is used as the join key to join these two cross-site events, right? But they join arbitrary events, so like all of your browsing can be linked up to this one cookie in theory. How could it be improved? We could internally join this data in the browser. So when you see an ad, we could register something in like custom new browser storage. And when you buy something that was like pointed to by that ad, that would join up with that event in the internal browser storage. And you could have a communication path from the browser to something like PPM, where we have this data, we want to compute something like a histogram. Maybe we want to learn something like, what are the counts of conversions, like purchases per ad campaign. So the x-axis is ad campaign, the y-axis is number of conversions. We can use PPM to kind of generate a data share split that encodes that histogram contribution, send that up to PPM, and the ad tech could learn aggregate statistics like just a histogram of the counts. And this doesn't reveal any user data directly; it only reveals aggregates. So there are a whole bunch of like cool use cases to think about. I know there was a lot of talk in the chat about differential privacy, and this is some formal privacy that we could add within the PPM system to ensure that the output of PPM is private. So that's something we're looking into. There's a lot of interesting research that's related to kind of the heavy hitter stuff about how do we report these histograms when they're like really, really, really big, like you are running millions of campaigns or you want to do like all sorts of different crosses. We're really interested in systems that can help train machine learning models. In some cases, there are results that show that even just aggregate histograms could be used to train like logistic models, but we're looking into more sophisticated mechanisms. There's rather than conversion measurement, we could look at reach measurement, which is asking like how many distinct users saw my ad across many different websites. So this is kind of like removing remove duplicates operation. And we're interested in exploring we have this conversion measurement thing, but maybe there's something that's more generic that we could use for like a more basic browser primitive. And I think that's my time, but yeah, happy to answer questions after everyone else is done. Thanks.
Very much, Charlie. So now that's the end of the use case presentations. So we're going to open the floor briefly to anyone who wants to ask about any of those use cases. Okay, so I think we're going to go ahead and move on to Richard now. Thank you.
So I sent a request to share slides. Ah, there we go.
Yeah.
There we go. Share. All right, so yeah, this is pretty different. So Ecker talked about protocol. We had a couple talks about use cases. I'm here to talk about kind of the substrate. And the label we are using for this is verifiable distributed aggregation functions. Thanks to Chris Patton for that name. Context here is that, like many things in the IETF, we need some complicated crypto for this. And so we're doing some parallel work in CFRG, and it goes alongside the the protocol work in the IETF, to kind of to specify the complicated crypto bits in a place where we can get cryptographers' eyes on them as opposed to just protocol nerds. Just highlighting some parallels here. TLS depending on cryptographic primitives that CFRG defines. MLS relies on HPKE, which we did in CFRG. And so for this PPM work, we're defining this VDAF or VDAF, depending on how you want to pronounce it, defining this as the kind of cryptographic abstraction that that PPM relies on in CFRG. Now, if you look at the draft, it's kind of in two parts. We define an API that is the abstraction PPM is supposed to rely on. So the idea is that we have multiple instantiations that do various flavors of this private aggregated measurement dance that all behave in a close enough way that we can define a common API over them and build protocol around that API. And this provides a way, that we can build a protocol without having to care about the details of the cryptography, and provides a target that cryptographers can look at and design new schemes. And if they plug into this API, then they can presumably be used inside of PPM with more quickly and more easily than if they'd been designed kind of completely from scratch using a new, not reusing that construct. So what I'm going to talk about here is mostly the API, and I'll talk a little bit about the instantiations at the end. So as Ecker outlined, so just briefly to define like what we're actually doing here. So the idea of this VDAF is to kind of capture the critical things we need the cryptography to do inside of PPM. So kind of working back to front, the aggregation bit is the idea that the inputs to this process are individual measurements, and what comes out of it at the end is an aggregate measurement over those individual measurements. Distributed in the sense that it's distributed among a bunch of aggregators. That the computation of that aggregate is distributed over those aggregators, and the privacy properties of the individual measurements are assured by non-collusion among those aggregators. And finally, it's verifiable in the sense that the aggregators can check that the inputs have meet some properties. As Ecker pointed out, there's risk in this sort of distributed scenario that the measurement results that get reported in by the measurement points could be corrupt, they could be invalid, that could flow through and lead to a garbled aggregate. So we have some checks in here that allow the aggregators to verify that the measurements they're getting meet some definition of correctness. Now, exactly which definitions you can apply varies a little bit by the instantiation. So looking at how this kind of plays out, this is the kind of classic measurement scenario. This is how a lot of telemetry works today, where you have a client out there, actually many clients, but I'm only going to portray one on this slide. You have many clients out there collecting measurements of something, where people clicked in an application or whatnot, and reporting that back to a collector. And as you've seen various takes on this on the last few, but the idea here is that we're introducing this aggregator tier in between the client and the collector. And the idea of these aggregators is that the client shards each measurement out to individual shards of the aggregators, such that you can only make sense of that measurement if you have all the shares. That's how we get that non-collusion guarantee. The aggregators then go through this process of what I've called the term we use in the draft is preparing the measurements. So that includes verifying that the measurements are correct, are acceptable, that they're correct, and transforming them into an aggregatable encoding, perhaps. That's necessary in some realizations. So once you've kind of taken the individual measurements and prepared them, you aggregate them. This is kind of where you do that step that Ecker's over. You add up the shares into a share of the sum. And then finally, the aggregators send their aggregate shares over to the collector, who unshards them to get the final results. So this is kind of the data flow view of the same thing. I think the interesting thing here from a kind of protocol point of view is you notice there's a kind of back and forth thing at the preparation stage. There is a need for some chattiness, some interaction between the aggregators in that verification process to enable a distributed verification of the correctness of the input shares. But otherwise, hopefully this kind of explains the overall process. Also, the kind of little gray squares that parallel to the output shares are meant to indicate other output shares, with the idea that an aggregate share represents the aggregation of the output shares over a batch of measurements. And as was pointed out before, it's up to the aggregators to do things like enforce minimum batch sizes, define what a batch is. So that's kind of the data flow. This is how we've described that API in the draft. Again, just kind of using notations here. So basically, what the VDAF draft defines is this API and how a couple of instantiations fulfill that API. And then PPM's job is to do the plumbing, to get the inputs and outputs of these local functions to the right places at the right time, so that at the end of the day, you can unshard into a measurement that's meaningful to the collector. In the draft, we define a couple of constructions. I think Ecker probably described these in a little bit more detail. PRIO is the one that I think ENPA is based on. The version in the draft is I think has a few more changes on top of what's in ENPA, but that's one where we have a fair bit of deployment experience. And then the HITS protocol is the one that lets you get distribution on strings. And there's been some discussion in chat about whether, possibly we could fit something like star in here. It's kind of the idea of the draft, is that we can look at not just these two, but also fitting other things in under this umbrella, so that we can have PPM as a generic construct into which we can fit multiple different cryptographic realizations. There's a few implementations so far. This is kind of, we have the one that supports ENPA with PRIO v2. We've got some early implementations of distributed point functions, or what supports kind of the inner loop of hits. And there's some work on various PRIO instantiations. I think one of the things interesting that comes out of this is that we can start to do some measurements of the cost of doing these algorithms. If you look at the papers in which they're published, there's, it might look intimidating in terms of the amount of data that's getting sent around, the amount of computations being done, but with these implementations, we have some early data about the expense of, in terms of computation and communications overhead of doing these private schemes. And, your mileage may vary, but it seems tolerable to first order. Let's say that. So yeah, I think that's all I had. Yeah, a couple references.
Much that puts us right on schedule again. Much appreciated. So, any questions for Richard about any of that?
Eric?
Hey, so in one of your slides, you had the aggregators sort of with lines between them, and in the PPM spec, I mostly see sort of the helpers not connected. Are we thinking about a protocol where we might imagine enabling a topology that could have helpers sort of communicating with each other, like some MPC protocols allow for? Yeah, this slide.
Yeah, I admit that I'm not an expert on kind of what the PPM protocol is doing right now. I've mainly been stuck down at this layer, but I think my understanding is that you can emulate it. This kind of looks like a broadcast channel, and if you have a leader that is connected to multiple helpers, you could have basically a star topology that over which you can emulate a broadcast channel. So if a helper needs to, for instance, in the API we've sketched out, we structure the preparation process in rounds where the input to each round is the output of the previous round from all aggregators. So I think in the PPM content kind of communications model, you can envision all helpers submitting their outputs from the previous round, and then the leader distributing those outputs out to all of the helpers for the next round.
Got it.
Yeah,
cool.
but just to add on to that, yeah,
Please.
I think basically the assumption is that the communication is probably mediated by the leader, but that's the assumption. That's embedded in PPM, not embedded here, and certainly if that turned out to be not a workable function, we figure something out.
Yeah, I mean, I think it might be useful for the leader to be able to, coordinate helpers directly connecting to each other just to minimize communication overhead. But as long as that's sort of within scope or whatnot, or
Absolutely.
considering, I'm fine.
Yeah, we have this is like a straw man thing. It's not a like the protocol may change radically, I imagine.
Thank you.
Chris Patton, I saw you briefly flash up in the speaker list here. Did you have a comment?
So I don't need to reiterate it.
Okay. Seeing no one else in the queue, thank you again very much, Richard. We're going to go ahead and move on to, well, first we're going to call, let me bring the slides up here. So we're going to move on to a call for expression of interest from folks in this. Just to make sure that there is enough critical mass behind this, aside from the people who have presented here, we'd like to ask who in attendance is interested in working on this technology. I'm trying to figure out, we probably don't need people to speak to this necessarily, although we're very happy to hear what you have to say on the topic. I'm also going to throw up a quick show of hands. There we go. So go ahead, Tommy.
Hello. All right. Cool. I did the show up. I just wanted to speak up a little bit to mention, from my perspective, we definitely have already we're using stuff like this, and seeing something like this be standardized and taken on by the working group would be something that would be a positive thing. So, we didn't do any of the presentations here, but we're definitely interested.
Thank you. Does anyone else want to stand up and speak specifically to it?
That we did get, I guess two things. One, that I think everybody who would speak is interested in working on this, just so we're all clear. And second, if you look at the, there's a bunch of people in the Jabber chat that are saying they're interested, including Facebook and whatever Thursday.
Oh, excellent. Thank you. All right, Robin?
Is the audio okay?
Yes.
Great, thanks, Adam. Yeah, this is so this is a personal comment rather than anything on ISOC's behalf. I would be interested in at least following the work, and I would also have a personal interest in seeing to what extent it can be used to test the growing and increasingly mature body of work on what's sometimes called value-based design. So in other words, what systematic approach can you adopt for the design and innovation process that ensures that ethical factors and values are considered at each relevant step? And I think that would help clarify a lot of the comments in the chat about along the lines of, yes, but this happens already, or well, this only works if you can assume there's no collusion, and so on. Because what it does is it flushes those assumptions out and lets you determine whether you want to design in a way that is compatible with those behaviors, or actually perhaps even conceivably inhibits those behaviors.
Okay, thanks. Yari?
Yeah, I just wanted to briefly mention that I do think this is exciting technology, and we should work on that. I can see other types of applications. We mostly talked about the sort of application type, browser type of things, but also many types of networks could probably use this technology to do a better job at collecting information that needs to be collected for various debugging and other reasons. The only piece that I was sort of a little bit concerned about was this advertising piece, and I sort of just as a personal opinion, I had some reservations about the browsers working with advertisers, even though I do recognize the need to do something better than we do today. But maybe there's also other paths for the advertisement problem, trying to prevent information flow rather than collaboration. But I don't work for the advertisement in the industry. So anyway, I like this. This should go ahead.
Thank you. Wendy? So we can't hear you, unfortunately. There may be an incorrect input device selected or something along those lines. Okay, I think we probably need to let you try to work that out and get back in the queue. Thanks. Ted?
Thanks. I basically got in the queue to answer one of the BOF questions. That's, do I think the problem statement is clear, well-scoped, solvable, and useful to solve? And I think one of the things that kind of worries me about the way it was presented today is that it's talking about what seems to me to be a set of problems and aggregating them into something which seems to be arguing that a single solution is the best solution for each of the ones in this set. And I would be very interested in seeing the work go forward, but I would suggest that in scoping the work, that you do it in a way that allows you to say the best answer for this member of that set may be different from the best answer for that member of the set. In particular, the set of problems you're dealing with something like identifying bad URLs, etc., doesn't really involve tying two actions together in the same way that an ad conversion does. So it may be that there are simpler mechanisms or only a partial use of this system that would still satisfy those, where invoking the full thing might be more difficult and not necessarily buying you everything that it would need to buy you when you had the conversion case. So I think as a set of problems, it's interesting to work on, but I would prefer that we take it as a set when we take the work in.
Thank you, Ted. Philip?
Yeah, I like this stuff. I don't think that we understand the problem, but I want to do it anyway. I am a bit worried that we seem to have gone straight for the real highfalutin cryptography rather than measures like, let's just encrypt log files as they're produced rather than having them sit in plain text ready to be stolen. So there's a bunch of real bread and butter issues I think that we need to do as IETF before we do the stuff that really excites us. The other thing that I point to is this has been presented in terms of a network realization. I think that the more immediate and more useful use for this would be to assist work like the stuff that my wife does, analyzing workers' compensation claims. In that there you've got an enormous amount of really privacy sensitive data that is aggregated together and then she analyzes it. And so that's not a network application, but that transition from I have this large amount of data, I would like to pre-process it into a form that it can't then leak in a dangerous way and analyze it in that form. I think that that technology would be very useful disconnected from the whole network case. And it might make for some starting problems that are rather simpler than trying to think about how do we secure the web.
All right, thank you. Chris. So there we go. So Chris appears to have disappeared. He's showing us offline. Let's move on to Wes.
Thanks. So, in general, I think this is an interesting problem to look at, and it's certainly something that we could consider doing. It's, as Ted said, it meets all of the BOF criteria, except for one oddity, right? That this solution is really designed to help us protect ourselves or protect end users from good people, right? Because it has no ability to prevent all of the evil sites and the evil mechanisms and evil ad trackers that don't want to use aggregation because they're deliberately trying to track individual people. And I think it would be sort of fair to say that this cool new technology really helps you protect you from companies that may already be behaving reasonably in the first place. And that doesn't mean that it's not worth doing, but there's a security consideration sections I'd be considering writing.
Looks like Chris is connected again, so let's go ahead and take him next. Thanks.
Yeah, sorry about that. I just wanted to echo something that Richard was saying in the chat, and perhaps ask us to take a step back from the advertising use cases, and recognize that this pattern that we're seeing across the industry, across different problem domains for collecting these aggregates, be it in telemetry for browsers or exposure notification for COVID, or even bandwidth measurements in the case of Tor, is very, very common. And I think it's certainly true that we have confidence in the general shape of the problem. That is to say, we need to collect these aggregate statistics to answer certain questions. And it's whether or not this is harmful or helpful for the purposes of web advertisements and conversion measurements in a privacy preserving way, I think is a good question to ask. But that does not, I don't think that takes away from the very valid use cases that were also presented here that could certainly be improved by a more privacy preserving protocol. So I'm very strongly supportive of this work. It cuts across so many different problem domains and use cases, and it's kind of inevitable that it be standardized somewhere, given how important it is. So that's all I want to say. Thank you.
Thanks. So we've closed the queue in the interest of making certain we have enough time to discuss the proposed charter. Although, let's go ahead and move on to Ecker here.
Yeah, so I would make a number of points. So first, I think Ted's point. Yeah, I mean, this is a toolbox that has a variety of different tools, and I think that the one way to think about this is that the PPM protocol is the toolbox and the VDAP is the tools. And so the idea is not to define any particular measurement thing. Is to define a set of mechanisms which could be used for taking different kinds of measurement, and then individual applications they layer on top of those tools. So that will be true both in terms of the which VDAPs exist, and it will also be true in terms of like how you build applications on top of the VDAPs. Because I mean, the one thing about this is like you got a thing that basically says I can collect counts, right? But like, what do you do with those counts is an important question, and one that we don't pretend to define. It's I do see some over-indexing on the ad use case here as well. There are a lot of use cases that are not ads, and in particular, like there's nothing ad specific to any of this. All the ad specific work which exists will be over somewhere else in PAT-CG. So I mean, this is about building a set of tools for measurements, and ads are really one application measurement. With that said, I do think that this question about like about this is for letting good people do good things. I think there's 2 points about that. One is that there are a lot of applications where, as Wes says, good people want to take measurements and want to be able to like bind themselves so they can't cheat you. And so they can't be collecting the data they don't want to have. So that's application case 1. I think application case 2 is that there's been a lot of like attempts to look at what it would take to like reproduce parts of the ad ecosystem with better privacy, because like I think we all agree ads are not going to go anytime soon. And one of the pushbacks that one gets once it's doing that is it will have a negative impact on the ecosystem as a whole. And like I'm not I think Firefox has already deployed a bunch of anti-tracking technology, so like I'm not like all in on that, but I think there's a real concern people have. And so the idea is not that we'll only simply offer these alternative technologies and then people will use them and third-party cookies. The idea is that these will be offered alternative, and that will eventually attempt to deprecate the existing privacy-invasive technologies.
Right. Thanks, Ecker. Charlie.
Yeah, I also wanted to respond to Wes and some of the comments in the chat, just mostly to +1 what Ecker said. But yeah, on the Google end, we're definitely looking at like helping this tracking problem on the web with kind of a 2-pronged approach. Like one is having a well-lit path where we can recover use cases in a way that we know is privacy preserving. Something like PPM could fit into this story. And once we have kind of a foundation where some of the use cases that we think are important to maintain the ecosystem are there, then we can go ahead and remove kind of the bad stuff that we think is bad for user privacy. So this question of like, oh, only the good guys will do it and the bad guys will use this other stuff, like here, I think the platform can really mediate this. And if we think that the platform provides a good enough foundation, then we can remove the stuff that we think is bad for user privacy. And this is like our strategy that we're trying to do on Chrome, where we're investing all this time trying to come up with new browser primitives, and also we have like a timeline where we want to disable third-party cookies and deprecate them. So yeah, I think this is like a reasonable point, but it's it's something that we're looking into as like a long-term strategy.
Thank you very much, Charlie. I do want to give Wendy an opportunity to come back in if we think we've solved the audio issues. All right. Okay, so let's go ahead and move on to the charter then. I have it up here in front of us. We've broken it into two sections. It's probably not terribly useful for me to try to read through it directly as it's on your screens. But we want to go ahead and take some comments here. I see our area director has stepped up.
Sorted out and told us to move on.
I'm sorry, we missed the first part of what you said there, Roman.
Wendy said that she is not going to be able to get her audio working and told us to move on, but she appreciates the opportunity for the slot.
All right, thank you. So this is the current proposed charter, or at least the first half of it. I want to go ahead and open the floor to comments on the formulation that we have here. And recognizing that people are still reading, I'm going to give it a bit of time. Okay, I'm going to go ahead and skip on to the second half of the charter, which is where a lot of the meat is. Specifically, this second paragraph talks about exactly what the working group will be doing. Florence.
Thank you. So thanks for all the presentations. It's been really interesting. So most of the presentations today were about use cases, but there's nothing about that in the charter, I don't think, although I can only see the second slide now, or I don't think currently in the draft. I think that would be a useful thing to kind of document somewhere.
All right, thanks, Ecker.
I think we were up for that. I guess I think the one thing we're trying to do is with the use cases motivational, because I think like these are generic techniques, but I think we've been more than happy to like write down like enough motivational things to understand why you want to collect any given statistic. And just to say something, Shavanja asked in the chat, is there room for multiple multiple instantiations of the same basic task? I think absolutely. So I think, for instance, if there's a better mechanism for collecting heavy hitters than hits, which is relatively expensive, that would be like something like there's absolutely room for. And I think like I'd certainly be interested. I think I want to build something where like as new cryptography gets developed, we can add it, and I want to build something where we have multiple mechanisms that like support the same basic thing. I think the only question I want to make sure is like if we have something that's like radically different in some way that doesn't match up, then we have to ask, would it be better to make a new protocol or better to fit it in? But like I'm like definitely pro fitting new things in.
Thanks, Siobhan.
Yeah, I just wanted to say that that's encouraging. I just want to make sure that currently the charter I think would kind of rule out some of the ideas alternatives to achieve the same goals. So I think the charter would need some tweaking.
So specifically, which aspect of it?
I think if you go to the previous one,
Okay.
previous slide, sorry. I think like splitting measurements between multiple non-including servers, like I think that is like a class for techniques for achieving this goal of privacy preserving measurements, but I think you could do it in other ways as well. I see there's some support to rewrite text, and I'm happy to send a PR.
Thank you for the clarification. Okay, Jim.
I think the charter needs to say something about use cases and threat models. I don't have any formal words for that at this point, but I do think that's the important thing to capture here, because if we're going to be developing multiple solutions, as Ted was alluding to earlier, there might be different threat models that apply to them rather than a single overarching one. And I think it would be good to make sure that information is clearly captured when things are developed. And obviously that needs to fit into the charter. Cheers.
Thank you. Eric.
On a similar line, actually. There was comments in the chat earlier about sort of differencing attacks and simple attacks, and comments that differential privacy would be required, and that the VDAFs have, you know, sort of have the scope for that. Is it meaningful to like say that these will support privacy respecting incorporation values without having some definition of what we mean by a private value, or should that be here, or should that be at the VDAF level?
All right, thanks. Charlie?
Yeah, I just wanted to, I guess, drill in a little deeper in the charter of like what aggregation actually means. And it might be good to have maybe like a definition there. I see like with the server can't learn the value of individual measurements, which maybe that suffices to say, as long as that's the case, you can't have aggregate measurements. But some of the use cases that we're considering, like, you know, don't very neatly fall into this realm of like you're learning in aggregate. Like, you know, if you learn like a private ML model that you can verify is, you know, differentially private or something like that, would we consider that an aggregate? Like maybe not. But it would be great if there's, you know, at least from our perspective, I think it would be great if things like ML models fit within this scope of the charter.
All right, thanks. Andrew.
Yeah, just adding to the earlier point, I completely agree with the idea of adding in the use cases, but just to echo a point that's come up in the chat, I think also consider adding abuse cases and ideally mitigations as well, which might help alleviate some of the concerns about some of the dark practices in this general area. Thanks.
Thank you. Watson.
Watson, I'm relaying a message from Wendy in the chat. She wrote, I'm just going to voice support from W3C for this work, as there's work in incubation that could use it.
Thank you. Stephen.
Yeah, just on the use cases thing, I think, given that this, I think, is probably pretty good technology that could be used well, I'm not too worried about documenting use cases, and that could be a bit of a time sink. But given that this good technology could be abused, I think effort spent in that direction would be much more valuable, particularly if we find ways of mitigating abuses that we see.
Okay, thanks. Nick.
Nick 30, CDT.
thanks for presenting all of this, everyone. On the charter, I had 2 questions or concerns for now. One, I think we're talking about abuse and things like that, but I also think there's a lot of the privacy that depends on assumptions about non-collusion or about how the client is going to find the different servers or configure them. And I'm a little bit worried that that's all getting marked out of scope in the hope that like maybe we can just ignore that problem or someone else will fix it. I guess I think we should be discussing it if we're going to put a lot of effort into the work of the protocol that depends on those things. The other concern is about the name. I think maybe it's come up a little bit already in the chat. I think priv is both very confusing, does not describe the work that's happening about privacy preserving measurement, and actively misleading that this is the group doing everything about privacy or incorporation of values. Sounds like a very general concept that I would support, but that this charter is not related to. So I think it's actively misleading. We should change it.
All right, thank you. Nick, I'm going to ask that you send some concrete suggestions for your first bullet point to the list if you have some time to do so. Thanks.
Sure.
Chris.
Plus one to that, like I think priv does seem overly broad. But also I wanted to address, I want to talk about the abuse use cases people are talking about in chat. So one of the things that was brought up is like, what about clients like trying to like corrupt the computation by sending bogus inputs or something like that? So that form of abuse is something that we're explicitly trying to rule out. So so like a VDAF is verifiable in the sense that invalid inputs can be detected and removed from the output of the computation.
All right, thanks. So just for clarification, this is addressed at Stephen, when we're talking about abuse cases, is that the kind of abuse you're talking about, or are you talking about like abuse of the actual data being collected?
So again, pardon my ignorance, it's vast. But so for example, if this technology could be used to measure things in in aggregates that are too small and that become exposing, or if some application had some kind of opt-in mechanism and then it was possible to change what gets measured in ways that are damaging for users, those I think would be kind of abuses that are a bit less concrete than the example given.
All right, thanks. Yeah, I was hearing what I thought were 2 senses of abuse, and that appears to be the case. So thanks for the clarification.
But I'm explicitly not asking that we try and fix everything, because it might not all be fixable. But if we can think about it in detail and propose what mitigations are possible, then I think that would be good.
Thank you very much, Yari.
Thank you. So +1 on the name confusion issue, +1 on talking about the abuse cases, and I think that's mostly by the whoever is doing the measurements, not so much about the abuse by the user. I think the user should still be able to produce the data that they want to produce, as long as it's sort of within bounds. The other thing is that I think maybe there's some room for the discussion of opt-in, opt-out type of solutions, and if we learn from some other protocol cases, like for instance in Quick, there's the spin bit where there's an arrangement that some fraction of users are automatically always excluded from spinning in order to create this set of users that don't do a particular action. And similar techniques might actually apply here, that you automatically exclude some set of users and then you sort of create this opportunity to not do this, and users can opt out without being targeted as opt-outers. And so I think that kind of thing would be important. I don't have the specific language for the charter, but maybe something about enabling opt-in and opt-out, or realistic opt-in and opt-out possibilities. Thank you.
Thanks. Hecker.
Generally, just the opt-in thing. I mean, generally, these are configuration points of some kind, and clients I think the question of exactly how users decide whether that got actually want to engage is like not generally something we worry about too much in IETF. The point Stephen is making are absolutely correct. There's like a whole pile of material that has to be done about ensuring that the system, the box the system is in, does not allow for abuse by the collector or by the various aggregators, and that's a big topic that like absolutely have to make sure we hit properly. There's some work already in the document about it, but like it's insufficient. So I think I would I'd love to see somebody suggest some text, but I think absolutely having like some like I think having something in the text that we had to work on, actually like addressing those topics would be really important. And we certainly.
Okay. All right, Martin. Just to Yari's point, a lot of the systems that are being described here allow people to opt out of the system without apparently opting out. They can generate the inputs to the system that appear to all intents and purposes as valid inputs to the system, but they're not actually contributing any values to the system. And that's actually a useful property that is exploited in various ways. So I think that capability exists. I'm not sure that we need to put those sorts of things into a charter. I do think that we need to include some of the, I think we need to include something generic about abuse. There is something very specific about abuse in here, about proofs of validity, but I've spent quite a lot of time thinking about things like Sybil attacks on various manifestations of these sorts of protocols, and those would be interesting things to have, at least in the auspices of the group.
So a slightly different thread that I meant to ask a while ago. Has there been any thought put on what type of ecosystem we really want to develop with this technology? Let's consider the fact that collectors need to take data from helpers and leaders, essentially. And are we expecting a small number of helpers and leaders that will be accepted by particular collectors, or can I and Stephen stand up our own helpers and leaders and expect everything to accept data that we submit to it because the two of us agree that we trust each other, but the collectors, are the collectors only going to accept data from certain places? And so we end up with either a very small, very centralized ecosystem, or a much more flexible framework.
Yuri?
Yes, so just a quick response to Martin. So that's really good news, and I wasn't looking for documenting any of that detail in the charter. Perhaps the high-level bit about there being effective opt-out mechanisms could be in the charter. Thank you.
Thanks. Ecker?
Answer the Wes's question. I think there's a bunch of like compatible models. I think that the important thing to remember is that the person who going back to the threat model I put up earlier, right? That the collector has to trust the aggregators, but the clients also trust the aggregators because the aggregators are responsible for serving the client's privacy. And so, as a practical matter, I would anticipate that there'll be a non-gigantic number of different aggregators, because fundamentally you're trusting them to behave correctly, right? So what you suggest, what you and Stephen probably doesn't work on, except for like maybe I'd be willing to send my data to that. But because people probably relying on the rotations of the collectors, the aggregators. But I mean, this is compatible with like an arbitrarily large number. I would expect to see really two models that we talked about. One of which is people who operate just as aggregators and are basically their job is to ensure the safety of the system, and then people who operate sort of like a more global system where it's like, I don't know if you see Amplitude, but it's like, look, I am like data collection as a service, and like, I contract with several different aggregators, and that's how I provide the system in a box. So I bet this is two models, but there's nothing really centralized here. There's no reason, like every, there are plenty of like trustworthy entities in the world, and so there's nothing that basically requires like aggregator, the collector A work with the same set of aggregators as collector B.
Chris.
Bump what Ecker just said, but also kind of point out that something that we've been working on in the protocol is lowering the bar of entry to running this system as much as we can. So there's this sort of asymmetry between leader and helper. So the leader is, and this could change depending on what people's needs turn out to be. But what we have been thinking about so far is the helper should be very, very cheap to run and operate. And a leader is inherently more expensive because it's getting measurements directly from clients. It has to store them for some amount of time before they can begin processing them. How much you have to store and how long you have to store it depends on the VDAF you're running. But I think this is one of our goals, and I think this is important thing to keep in mind. Regardless of like how the ecosystem pans out, we want to make the bar to entry as low as possible, I think.
All right, thank you very much. So at this point, we'd like to go ahead and move on to some questions to inform the area directors in the IASG about community interest for this. I'm going to go ahead and bring up polls for each of these, but also at certain points, we're going to ask that if you are not in support of forming the working group, that you go ahead and put yourself in the queue. So for the first question, I'm going to ask who supports a working group with this charter. And this is modulo any changes that we've discussed today or come up in the mailing list shortly afterwards. And again, if you don't support the charter and have not yet spoken, we urge you to join the microphone queue. Okay, we seem to have slowed down, so thank you very much for the input on that. The next question we're going to ask is, do we think, do you have something to say, Alyssa?
Well, maybe we should take them one at a time so we can hear from the folks who did not raise their hand or explicitly left their hand down.
Yes, I don't see anyone in the queue though.
Okay, I just wanted to make sure it was clear to people that now is the time to do that if you have something to say about it.
Yes, thanks.
Okay, can move to the next one.
Thanks. So for our second poll, do we think the problem statement is clear, well-scoped, solvable, and useful to solve? Ted, go ahead.
Is this also a modulo of the discussion in the chat? Because there was a good bit of it that really did help.
I would imagine yes. I haven't been following the chat myself, but I would hope that any salient points of that would also be brought to the mailing list. Sorry, I'm looking at the...
Yeah, I mean, the answer to that is yes. I mean, the charter itself is going to require some edits. We've had some good kind of feedback here, so consider the chat and the presentations.
So again, if you have concerns about the scoping here and have not yet spoken on them, please add yourself to the microphone queue so that we can understand better your position. Nick, go ahead, please.
Okay, partly, yeah, okay, doing polls like this is tricky because we're chatting about possible variations. I agree, but I think we have this like very open question about are use cases and abuse cases going to be put into the charter, or are they going to be a work item? And until some of that is settled, until we actually are going to define them, then I think that it's hard to conclude that the problem statement is completely clear if we're not actually agreed on the use and abuses.
Thank you. Okay, Robin.
And again, a personal statement, not on behalf of ISOC. I think the discussion in the chat about even the name of the group, and most of the proposed names did not have the word values, raises questions about the scope and intent of the group that are fundamental enough that question 2 is very difficult to answer, as Nick said.
Okay, thank you. All right, so Ecker, go ahead.
People seem to be like all worked up about the name. I just want to say like what happened with the name is like we were calling this PPM, privacy preserving measurement. People thought it was too close to IPPM. I like got punchy and like tried to figure out how to make it say priv. So like really like there's like that's what's going on here. So like if people don't like that, like suggest something else because like the like every letter in there was like constructed to make it say priv, not for any actual reason other than that.
Thank you. Okay, and then the final 2 questions that we're going to have, typically we would have a raise of hands of this in a physical room, because we do like to keep track of who exactly answered yes. But to do that effectively here, we're going to ask people in the chat, if you are willing to review documents associated with this working group, please respond with review. Okay, so I've seen on the order of 20 people respond so far. This is a very strong signal. And secondly, who here plans to be an editor for related documents? Please respond with edit in the chat. All right, great. Well, thank you very much. That takes us to the end of the things that we wanted to discuss for this BOF. I think this has been very useful, and I want to give a few moments over to our area director to speak.
Hi everyone. I'd like to repeat. I think we've had a successful BOF, and I want to thank everyone for kind of all their input. I think the chat was just as lively as the mic line, if not more. I mean, generally what I heard was there is a critical mass of interest in working in this kind of particular problem. There was repeated, though, tension I heard around this idea of, are we okay working on ad tech and the ad use cases, at the same time recognizing that that is the reality on the ground, and that there would be wider applicability of this tech, much larger, these protocols, much larger than that particular kind of use case. I think in the charter discussion, we're not ready to go with this particular charter. There were a number of really kind of helpful suggestions about how to polish that, and we'll double check and kind of confirm that. So specific things I heard reading off my list is things like, let's generalize the charter text to make sure we're sufficiently flexible so we can swap approaches, so it's not just pre-own the heavy hitters. We need to make sure that how we define aggregation doesn't restrict other kind of alternatives. We talked about the need for work items to document the abuse cases and talk about the threat models against all of the portions of the architecture. And then we had quite a lot of conversations that we need to tune the working group name. I don't know what the solution is, but that we would like a change there. And so I think the proponents seemed open to making kind of those changes, and those changes will be made, and then we'll bring that back for confirmation. But otherwise, I think we do have a critical mass, and we should kind of polish this to consensus, and so we can move forward. Thank you.
Thank you very much for everyone attending this. This was a very well attended BOF. Have a good rest of your day. Thanks.
For taking notes.
Oh yes, thank you very much, Peter.
And thank you to the chairs for bringing us all together and leading us through a good conversation.
All right, thanks all.
Peter, did you want to say something?
Oh, just thanks.
Okay.